A very good morning and warm welcome to one and all. As we can see, the title of this talk is quite suggestive about the proceedings of this session. We are going to establish a connection between Santili's most modern discoveries and the ancient Hindu philosophical thought known as Daivavad, fatalism, or predestination. The main objective of this paper or this presentation is to investigate the metaphysical implications of the Hindu philosophical notion of determinism in the light of Santili's path-breaking proposal as to determinism can be established in the limiting sense at the core of a black hole. Over a period of times, spiritual ideas turn into metaphysical notions and subsequently are established as scientific facts. Thus, there is always a region of overlap between these three categories of thought, namely scientific, metaphysical, and spiritual ideas, can be seen in the slide. There is a region of overlap. Now, coming to the main points of this discussion. Number one, EPR argument suggests that quantum mechanics is incomplete and can be made complete by accounting for the hidden variables therein. Number two, quantum mechanics is probabilistic and not deterministic. Number three, Santili shows that quantum mechanics is deterministic in the limiting sense, as suggested by Einstein, Podolsky, and Rosen. Now, Newton's laws of motion were written with the assumption that if we know the position and speed of the sun and other planets at a particular instance, we can accurately determine its state at any other point of time. This is known as classical determinism. So, following Newton's laws of motion, classical determinism in fact ruled for 300 years till the discovery of quantum mechanics. Coming to EPR argument, in 1935, in the paper called Can Quantum Mechanical Description of Physical Reality Be Considered Complete? Einstein, Podolsky, and Rosen said there could be hidden things we don't know about, and maybe we can come up with a theory that includes these hidden parts. So EPR argument, in fact, predicts about hidden variable theory. Now let us talk about three distinguishing terms in quantum mechanics, namely completeness, reality, and entanglement. EPR means Einstein, Podolsky, and Rosen suggested that there must be hidden variables that, if known, would fully describe the properties of quantum systems and remove the probabilistic nature of quantum theory and making it complete. Quantum mechanics, in particular, have challenged classical notions of reality by introducing principles such as superposition, entanglement, and indeterminacy, which suggests that the nature of reality at the quantum level is probabilistic and counterintuitive. The EPR argument also asserted that physical systems should have objective properties independent of measurement, even if those properties are hidden. Coming to the phenomena of entanglement in quantum mechanics, this is a quantum phenomena where two or more particles become connected in such a way that the state of one particle instantly influences the state of another, regardless of the distance between them. So, in fact, entanglement is a fundamental concept in quantum mechanics that describes a strong correlation between two or more particles, even when they are separated by large distances. When particles become entangled, the quantum state of one particle becomes dependent on the state of another, regardless of the distance between them. Quantum mechanics always advocates non-locality. EPR pointed out that if quantum entanglement is real and particles are correlated in the way described by quantum mechanics, it would imply that information about one particle state can be transmitted instantaneously to the other, even if they are separated by vast distances. This appeared to violate the principle of locality, which suggests that nothing can travel faster than the speed of light. Coming to Bell's theorem, which is the most fundamental theorem in quantum mechanics. Bell's theorem is a fundamental result in quantum mechanics that deals with the concept of local realism. This was proposed by John Bell in 1964. So Bell's theorem is the most fundamental theorem in quantum mechanics, which shows that no physical theory of local hidden variables can reproduce all predictions of quantum mechanics, and hence there cannot exist a hidden variable theory as was thought of by Einstein, Podolsky, and Rosen. In fact, Bell's theorem provides a way to test the validity of EPR argument experimentally. It examines the compatibility of quantum mechanics with classical physics, specifically with respect to the concepts of locality and realism. Now, subsequent experiments, such as those testing Bell's inequalities, have supported the predictions of quantum mechanics and suggested that certain forms of local realism are incompatible with the observed behavior of entangled particles. In summary, the EPR argument is foundational critique of quantum mechanics that raised questions about completeness and realism of the theory. It played a crucial role in shaping the development of quantum theory and our understanding of the strange and counterintuitive properties of quantum world. We again talk of classical determinism. EPR arguments suggest that quantum mechanics could be completed into a form requiring classical determinism, at least under limit conditions. Coming to quantum mechanical view. So according to quantum mechanics, atomic and subatomic particles do not have a specific well-defined position and velocity. Instead, they are in a quantum state, which is the combination of position and velocity. So quantum mechanics is probabilistic rather than deterministic. This leads to indeterminism in quantum mechanics. Now comes the work of Professor Ruggero Maria Santilli, which was a path-breaking seminal work, which was done over last 40 years by Professor Santilli, who developed novel mathematical, physical, and chemical methods and used them successfully for confirming the apparent proof of the EPR argument. Hadronic mechanics was developed by Professor Arun Santilli. It's a theoretical framework in theoretical physics developed by Dr. Ruggero Maria Santilli in late 20th century. It is an extension of traditional quantum mechanics that aims to describe the behavior of particles known as hadrons, which include protons, neutrons, and other strongly interacting particles. The primary motivation behind hadronic mechanics is to provide a more comprehensive and accurate description of hadronic matter and interactions compared to conventional quantum mechanics. In particular, it seeks to address certain limitations and challenges in the treatment of hadrons within the framework of quantum field theory and quantum chromodynamics. Here are some key aspects and features of hadronic mechanics. Unlike quantum mechanics, which is formulated in a Hamiltonian framework, hadronic mechanics is formulated in non-Hamiltonian manner. It incorporates new mathematics and algebraic structures to describe the behavior of hadrons. Hadronic mechanics employs a specialized mathematical apparatus known as Santilli's isomathematics to describe the mathematics of hadronic structures and interactions. In fact, Professor Santilli has rightly said that there cannot be really a new physical theory without really new mathematics, and there cannot be really new mathematics without new numbers. So Professor Santili went on to develop a new kind of mathematics, which we call as isomathematics, in the following manner. Santili submitted in 1978 an action-preserving broadening of 20th century mathematics called isotopic lifting, based on associativity preserving generalization of the conventional product A into B between generic quantities A and B, such as numbers, functions, matrices, operators, etc., called isoproduct, defined as. So this is the fundamental uh, discovery or fundamental innovation by Professor Santili, where he defined isoproduct in the following manner, like this. This is the ordinary product A cross B. This is given by this is iso product defined in a particular way. This product hat, and this gives this is here T hat, which is called as the isotopic element, which is always positive. Coming to next slide, where T hat, called the isotopic element, is restricted to be positive and definite, but possesses otherwise an unrestricted functional dependence on local quantities such as coordinate x, velocity v, energy, density, temperature, pressure, wave function, their derivatives, etc. T hat is defined like this, which is a positive quantity, the function of x, v, e, mu with usual meanings of those symbols. The above assumptions immediately allowed an explicit representation of protons and neutrons as being extended non-spherical and deformable charge distributions via realization of the isotopic element of the type T hat defined in this manner, where this is diagonal 1 by n1 square, 1 by n2 square, and so on. And this quantity n mu defined like this. Santili introduced the isotopies of numeric fields, which can be denoted like this. This is an iso field, where f hat is a notation for iso field as compared to f for field, and n hat is the iso number, iso product, and iso unit element of conventional numerical fields, which are denoted by f and product and I. These are characterized by iso product 1. This iso product defined in the iso field is given in the previous equation. And a generalized multiplicative unit called iso unit, which is most important. This was formulated by Professor Santili. Iso unit denoted by 1 hat, which is equal to 1 upon T hat, which is greater than 0, and where T hat is the isotopic element as defined earlier, and generalized numbers called iso-real, iso-complex, and iso-quaternionic iso-numbers, and related iso-actions are also developed. This is n hat is the iso number, which is defined as the ordinary number multiplied by iso unit, which is 1 hat. So in fact, with consequent formulations of iso-associate algebras on an iso field, with iso-complex, iso-quaternion, iso-numbers, and lifting of the functions to iso-function and iso-exponentiation, Santili lifted the whole mathematics to a new level, which is called as isomathematics. So action-preserving lifting of Lie theory into a non-linear, non-local, and non-Hamiltonian form was introduced. Today it is known as Lie-Santili iso theory, with iso brackets defined as this. This is the commutator defined in this manner, where star denotes the iso product. The action-preserving lifting of quantum mechanics into isotopic branch of hadronic mechanics, or simply isomechanics, is formulated on Hilbert-Muon Santili isospace H hat over the iso field of isocomplex number C hat, and it is based on the iso-Heisenberg iso equations for the time evolution of Hermitian operator Q in the infinitesimal form, denoted by this. So this is the iso commutator or iso quantities defined in this by this equation, and the finite form given in this equation with the following rules for basic iso-unitary isotransforms, where t hat is t into I t hat. This is isotime, and it is assumed to coincide with the conventional time. I t hat is taken to be 1. So Santilli also developed Schrodinger's iso equation. So iso differential iso calculus permits iso Schrodinger iso representation characterized by fundamental representation of iso momentum. This is the fundamental representation of iso momentum given by this, where psi is a wave function and t is the momentum, from which one can derive iso Schrodinger iso equation, which is most important. So iso Schrodinger iso equation is given by this, where everywhere hat denotes the iso of the particular quantity, and this is the Schrodinger's equation in the iso mathematical form, which is called as iso Schrodinger iso equation. Here E hat is equal to E into I hat is an iso eigenvalue defined over iso real field R hat, and E is an ordinary eigenvalue defined over the field of real numbers with specific iso commutation roots. The isotopic S hat U2 spin symmetry for extended particles immersed within dense hadronic medium admits an explicit and concrete realization of hidden variables of the type T defined like this. Determinant of T is 1. Thus, in iso equation, this is the iso product, you get this equation. In this equation, again, the Hamiltonian H represents all interactions of quantum mechanics, linear, local, and potential interactions, while the element T, known as Santillian, this is very important, the element T, known as Santillian, in recognition of its crucial role for the proof of EPR argument, this represents all new interactions of hadronic mechanics, namely non-linear, non-local, and non-potential interactions. It's crucial to note that in isomathematics and isomechanics, the isotopic element T is much smaller than 1, as it has been the case for synthesis of neutron from the hydrogen in the core of stars, the representation of nuclear magnetic moments and spin, new clean energies, and other applications. Coming to classical determinism again, Santilli has shown that extended particles in interior dynamical systems appear to progressively recover classical determinism with the increase of density and other characteristics. For Santilli, it was of utmost importance to select the isotopic element T, called as Santillian, an iso unit compatible with the studies of determinism. The main result is that the standard deviations of coordinates and momenta for particles within hyperdense media are characterized by the isotopic element that, always being small, very, very small than 1, reduces the uncertainties in a way inversely proportional to a non-linear increase of density, pressure, temperature, and other characteristics of medium, while admitting the value T hat equal to 0 under extreme limit conditions with ensuing recovery of full determinism as proposed by Einstein, Podolsky, and Rosen. As a result, Santilli developed isodeterministic iso principle, which states that the product of iso standard iso deviations for iso coordinates delta r hat and iso momenta delta p hat, as well as the individual iso deviations, progressively approach classical determinism for extended particles in the interior of hadrons, nuclei, and stars, and achieve classical determinism at the extreme densities in the interior of gravitational collapse. Now, coming to Hindu philosophy, in Hinduism, Hindus are supposed to be going through a cycle of life and death, which is called as Janma and Punarjanma. In his present life, one has to pay for his sins committed in his life and also gets rewarded for his good deeds in his past life. So the events in Hindu philosophy, the events which seem to take place without any cause are credited to his destiny or fate or doings in the past. Here, human life is portrayed as a fine blend of the ideals of individual actions called as karma and destiny called as daiva or fate. One is also able to use his free will to undertake good karma to improve his life in the next rebirth. So, the Hindu philosophical view, in short, is deterministic. It is a philosophical view where all events are completely determined by previously existing causes. Everything that happens has been predestined to happen by an omnipotent, omniscient divinity. Concluding this presentation, we come to the conclusion that most modern mathematical methods proposed by R.M. Santili point towards determinism in the limiting sense. Thus, latest science and oldest wisdom do have a region of overlapping that needs to be explored with the proper scientific spirit. Thus, Indian spirituality is being supported by most modern scientific theory developed by Professor R.M. Santili. These are the references for the readers. Thanks for watching this presentation. धन्यवाद, आपका आभार।